Hi Andres, can you briefly describe the factory automation demo that you will show next?
Yeah, hi Sylvia, thanks for having us, and of course I can. Our short video demonstration has been jointly prepared by Bosch, Nokia and Rohde&Schwarz, and it gives some insights into the performance that can be achieved with 5G in a real-world production environment. We conducted these tests at our Bosch factory in Stuttgart-Feuerbach. There we installed a 5G standalone private wireless network from Nokia, and then we jointly captured performance results using a radio testing solution from Rohde&Schwarz. The intent of the demonstration is to confirm that 5G provides the performance and quality of service that is needed to automate and digitalize manufacturing facilities and operations. And to this end, of course, we also implemented some first use cases based on equipment and components from Bosch Rexroth.
That sounds very interesting indeed. And this is precisely the purpose of 5G ACI, to bring members from different industries together to develop real solutions for manufacturing. So you said the demonstration was done in your facility. Can you please briefly describe the factory and what products are produced there?
Yeah, sure. Our plant in Stuttgart-Feuerbach is one of our Industry 4.0 lighthouse factories, and it belongs to the business unit Powertrain Solutions. That means we are producing parts and components for the automotive industry there. The deployed private 5G network currently consists of 8 small cells. It covers an area of around 10,000 square meters, and all the user data remains on-premise, which is in general very important for us.
Thank you, Andres. So then what is Bosch's vision of the factory of the future, and what role does 5G play in it?
Yeah, from our perspective, 5G will become the central nervous system of the factory of the future, with the potential to enable unprecedented degrees of flexibility, productivity, and ease of use. In our vision of the factory of the future, only the floor, the walls, and the ceiling of a factory remain static and fixed, and everything else becomes flexible, mobile, and easily reconfigurable. So 5G will connect mobile robots, automated guided vehicles, augmented reality glasses, wearable devices, and much, much more. All this is enabled by an unprecedented performance of 5G, for example, in terms of ultra-high reliability and very low latency, novel features like support for time-sensitive networking, TSN, as well as the so-called private or non-public 5G networks. These put factory owners like Bosch in the position to deploy and operate 5G networks in our own production in exactly the way we need it. However, we are still at the beginning of the journey, and activities like the one in our plant Stuttgart-Feuerbach, together with Nokia and Rohde&Schwarz, are important milestones on the way towards a more widespread adoption of 5G in the manufacturing industry.
Thank you, Andres. And now I'd like to welcome Jürgen Merkel from Nokia, also a 5G ACI member. Jürgen, so the 5G standards that support industrial applications is now on its second release, which was defined in Release 16. Already in the past, we've seen 5G industry cases demonstrated from many companies, including Nokia. So my question is, what are the main features you are showing here in this demo?
Hello, Sylvia. Yes, it's true, 5G has been around for a while. For example, at Hannover Messe 2019, together with Bosch, we demonstrated an emergency button on a machine where reliability and latency are of critical importance. This was then based on prototype hardware as well as prototype software, and also based on the non-standalone deployment model of 3GPP. In this demonstration now with Bosch and Rohde&Schwarz, we are showing real commercial available hardware and software, which is based on the 5G standalone model, which will be the preferred model for the industry to use. Nokia considers participation and membership in 5G Asia as essential in bringing forward the widespread adoption of 5G in the industries. Thank you.
Thank you, Jürgen. And finally, I'd like to introduce another 5G ACIA member, Mike Kottkamp from Rohde&Schwarz. Mike, now can you tell me what makes 5G different or more challenging to test in a factory than other wireless technologies?
Hi Sylvia, indeed there are challenges for any wireless technology that is deployed in an industrial environment. This is mainly because we face very stringent requirements in terms of availability, reliability, as well as stability of the network and its performance. Additionally, specific KPIs are more important in private industrial networks compared with public deployments. As an example, latency is a key performance indicator for industrial application, which requires dedicated or at least adapted test solutions. Obviously, at Rohde&Schwarz, we actively participate and also leverage the 5G ACIA discussions to optimize our test solutions, as you will see shortly. However, and even more important, we do operate own factories. Most of them are located in Germany. Therefore, we engage early in this ecosystem in order to deploy our own private 5G network, actually also based on Nokia infrastructure. We are active for decades in cellular communications, providing test solutions. But this is the first time we became an adopter, indeed an operator of such a network ourselves. Along with the experience we make, we expect this initial deployed network to evolve, adding enhanced functionality and covering additional sites.
Thank you very much, Mike. Now let's see this joint demonstration of industrial factory automation with 5G from Bosch, Nokia and Rohde&Schwarz.
Bosch, Nokia, and Rohde&Schwarz, as members of the 5G Alliance for Connected Industries and Automation, present a practical demonstration of industrial automation over a 5G standalone private network. 5G performance measurements were taken in a real-world production environment in Bosch's Industry 4.0 Lighthouse factory in Stuttgart-Feuerbach, Germany. It proves that 5G can provide the performance, reliability, and quality of service that is needed to automate and digitalize manufacturing facilities and operations. The real-world factory environment used in this demonstration includes Nokia Digital Automation Cloud 5G standalone private network solution. It is comprised of 5G NR small cells and a compact edge cloud server that provides the 5G core functions and supports industrial applications and services. Bosch Rexroth's Active Shuttle, a self-navigating autonomous transport system. It is connected to the 5G private network and receives, for example, routing instructions to deliver parts and material on the factory floor. A Bosch 4K predictive artificial intelligence of things video camera supporting mobile broadband applications. And the Rohde&Schwarz 5G measurement solutions for deployed networks. It is based on a passive network scanner and an active device which collects the RF parameters and the KPIs of interest for an established data connection. We have all heard of the theoretical performance metrics that 5G can achieve: gigabit speeds, millisecond latencies, 6 nines network availability, greater coverage, and massive machine connectivity. But what is the performance of 5G in a real-world factory environment? Can 5G become the universal industrial communication standard for the factory of the future? The test cases presented in this demonstration will provide real field results to answer some of these questions. Wireless coverage is important in a factory where production area can be quite large, as is the case in Bosch's industrial 5G testbed at its Feuerbach facility, which is 10,000 square meters. The factory floor is equipped with lots of machines and equipment with metallic surfaces that can impact the wireless coverage. This test case measures the absolute 5G signal power levels received at varying distances from the deployed small cell. Measured values in excess of -80 dBm indicate very good coverage conditions. At the same time, the background noise and the potential for interference in the factory environment is checked. To do this, we measure the ratio of the strength of a 5G signal to interference and background noise. The so-called signal-to-interference noise ratio, or SINR, at various locations inside the factory. This is what the active shuttle will experience as it moves around the factory floor. SINR is measured in decibels. The higher the decibel level, the better. SINR values in excess of 30 dB indicate a well-deployed and interference-free network. This value is the basis for the achievable data rates that are shown next. Massive increases in downlink and uplink throughput are expected in 5G to support the growing use of video for quality control applications in manufacturing operations. This test case measures the 5G downlink and uplink speeds available to support these high data rate industrial use cases. For the chosen configuration, with a downlink to uplink ratio of 7:3, data rates of up to 900 megabits per second for the downlink and almost 200 megabits per second for the uplink are achieved. Network performance with deterministic latency for strict industrial communications and control is essential for manufacturing assets to become mobile in the factory of the future. This final test case measures the round-trip latency of the 5G private network as seen on the active shuttle. On average, the recorded latency is about 13 milliseconds based on a standard ping test. Future latency improvements are expected with 5G Release 16 and 17 chipsets supporting ultra-reliable, low-latency communications. This demonstration shows the 5G performance of AGVs and other devices connected to a 5G standalone private network in real factory environment. The results for the test cases shown provide solid evidence that 5G can meet the performance requirements that manufacturers are looking for as they build their factory of the future.